This is note 61. Today our goal is going to be to just practice solving with trig. And as well, we're going to review some quadratics at the back end of this assignment. So, number 1. It says, describe each angle as it relates to the diagram below. Does it represent an angle of elevation or an angle of depression? Remember, an angle of elevation means you're going to be looking up at something, and an angle of depression means you're looking down. So angle 1 in this picture is from the bird's perspective. If I'm a bird looking down at a boat, I'm going to create this angle here. And because I'm looking downwards towards the boat, that's going to be an angle of depression. So I'll just put DEP for depression. 1b asks you to identify angle 2. Angle 2 in this diagram is made from a person in the boat. There's a line of sight looking up at the birds. So because they're looking up, it's going to be an angle of elevation. Angle 3 is again from a person in the boat, but in this case, with the same line of sight, if they're looking down towards the submarine, if they could see it, that would be an angle of depression. So looking down is an angle of depression. And then to finish this problem, angle 4 is created from someone in the submarine. Again, with the line of sight being here, looking up at the boat, that would be an angle of elevation. Number 2, find the value of x, round to the nearest tenth. So at this point, as you guys work with right triangles, you have to decide which way to approach the problem. Here, because this angle is 40 degrees, this is not a special right triangle, and I only know one side, so I cannot use the Pythagorean theorem. So here, I'm going to use SOHCAHTOA. So I'm going to first start by writing that down here on the side. So I'm going to use SOHCAHTOA, that's my reference, or sine, cosine, or tangent. So in this case, for this process to work, I'm going to first identify a reference angle, which would be, in this case, 40 degrees. Then I identify the hypotenuse, where the hypotenuse is always across the right angle, so here's my hypotenuse. Then, from the angle that I've chosen here, which is 40 degrees, the side opposite this angle is going to be this blank side, so I'll put O for opposite. And then the side next to this angle is the x, so this is my adjacent side. Once I've done that, then I can look at the problem and see which sides are usable for me. In this case, this opposite side is blank, so I really can't use it in the moment, so I'm going to ignore the O. So what I can use is adjacent and hypotenuse, or A and H. So scanning SOHCAHTOA, A and H is going to be here, so I'm going to choose cosine. So I can write cosine of the angle I chose, so cosine of 40 degrees, equals adjacent over hypotenuse. At this point now I can solve this equation by multiplying both sides by 125. So that cancels. And then here, this is now the job of the calculator. So if you go on decimals.com/scientific, you can press that in, and you're going to find that this is going to have a length of 95.8 feet, approximately. Number 3, again here we're being asked to solve for x. This is on a missing side here. So here you have a crane holding some maybe lumber or something. But notice how in this case this is a right triangle here. In this problem you can use SOHCAHTOA if you wanted to, like we did in number 2, but if you recognize this angle measure of 45 degrees, this is actually going to be a 45, 90. And so if you understand that this is a special right triangle, remember that we talked about in a 45, 90, we already know how the sides are going to relate to each other. So the sides relate in a ratio of 1 to 1 to radical 2. So we learned that in a 45, 90, because you have two equal angles, you have to have two equal sides. That's where the 1 to 1 ratio comes from. So in this case, if this side here is 60 feet, and it's across the 45 degrees, then this other side here, x, will also be 60 feet in this case. So this question you could solve basically by looking at the problem and not doing any work, if you can recognize that it's a 45, special right triangle. But again, if that is not obvious to you in the beginning, you could still use SOHCAHTOA and find the answer that way. Number four. In this case, here's a scenario of a sailboat and an airplane. And so if you think about the angle of elevation, if you're from the boat to the plane, then you can use this information to figure out how high the plane is in this little prompt. So in this case, 25 degrees is not going to be one of my special right triangles, so I'm going to go ahead and use SOHCAHTOA again here. So just kind of as a setup, I'm going to write this every time so I can get used to these three different trig ratios. So again, for this to work, I'm going to first pick a reference angle, so I'll pick the one that's given to me. Then identify the hypotenuse. Here the hypotenuse is going to be this blank side. I don't know this length in this problem. That's my hypotenuse. Then from the angle that I chose here, the side opposite 25 degrees is going to be the x, so I'll put an O for opposite. And then by default then, the adjacent side is 75 yards. Okay, in this problem, if I look at the way it's labeled, this hypotenuse has no value, so I really can't use it at this point. So I'm going to not use the h here. What I can use is the opposite and adjacent sides, so OA. So in SOHCAHTOA, OA is going to be here with TOA, which means I'm going to use tangent. So I'm going to use tangent, so I'm going to write tangent of 25 degrees equals opposite, which is x in this case, over adjacent. And once I have that set up, my job is then to solve the equation. So I'm going to multiply, in this case, both sides by 75. And then again, once we get to this point, this is the job of the calculator, or Desmos. And if you press that into Desmos, for instance, then here you'll find that the height here, or this missing side, is going to be approximately 35 feet. Alright, number 5. Again, another right triangle problem. In this case, again, 18 degrees is not special, so I'm going to use SOHCAHTOA one more time. So again, just to kind of have that as a reference, I'll write it here on the side. So in this problem, for this to work, I'm going to first pick a reference angle. So here I'll choose 18. Next, my hypotenuse will be, in this case, the x. So that's an h for hypotenuse. From this angle that I've chosen, 18 degrees, the side opposite is going to be 60 meters. So I'll put O here for opposite. Then my adjacent side is there in this case. So again, once it's labeled with H, O, and A, I can then look at the triangle and see what sides are usable for me. In this case, the adjacent side is blank, so I really can't use that. So I won't use that now. So I can use opposite and hypotenuse. So in SOHCAHTOA, OH is going to be here with SO. That means that I can use sine for this problem. So sine of 18 degrees equals opposite over hypotenuse. Now in this equation, this is a proportion. So here I can put this sine of 18 degrees over 1. And from before, we learned how to solve proportions using cross product or multiply butterfly. So I'll do that now. So x times sine of 18 is just x sine of 18. That's going to equal to 1 times 60. It's just 60. Then to finish, here to undo x times sine of 18, I can undo times by division. So I'll divide both sides by sine of 18 degrees. So that cancels out. So x equals 2. And again, as before, once we get to this part of the problem, this is the job of the calculator. So if you do that, you get approximately 194.5 meters. Number 6. Now in this question, you have a prompt here, but no picture. So let's go ahead and read this prompt and kind of sketch this up. A woman looks down from a hot air balloon. So she sees a sheep below and measures the angle of depression as 35 degrees. So let me take this first part here. Let me take this first part of the problem and draw it out. So there's a woman in a hot air balloon. So let's go ahead and draw a hot air balloon. So something maybe like this. And there's a balloon. Whoops, that moved the whole screen. Sorry about that. So that's about as good as I can do. So here's a balloon. And she's looking down. So there's an angle of depression. She's looking down at a sheep. And you can tell that I'm not an art teacher. So there's my sheep. Cool. And so at that point, I can label this angle of depression here. So she's looking down at an angle of 35 degrees. So here's a hot air balloon. So there's a lady looking down at a sheep at an angle of 35 degrees. If the sheep is 125 feet from where the woman is looking down from the balloon, so if the sheep is 125 feet away from where the woman's looking at it, how high off the ground is the balloon? So in this case, if I finish this picture, I want to find out how high off the ground is the balloon. So I'm looking for this missing side, looking for the height of the balloon. Now with that being said, I now have a right triangle here, and I can start to work this out. Now me personally, whenever I work with some of these little prompts, I like to redraw the triangle on its own, just to not get caught up in the actual story. So I'll do that now just briefly. So I'll put it in different colors. So all this really comes down to something like this. It's a right triangle. This is 125 feet. Looking for this side. And this is 35 degrees. So now there's no story. I'm just looking for this missing side. So in this problem, this is not a special right triangle, so I'm going to use SOHCAHTOA. So I'll stick with blue in this case. So I'm going to use SOHCAHTOA here. So I'll just jot it down here in the center. And then here, I'm going to pick my reference angle. So I'll pick 35 degrees. This is my hypotenuse. Again, from the angle that I've chosen, the side opposite is x. And this is my adjacent side. So in this problem, I'm not going to use the hypotenuse. So I can use here opposite and adjacent. That's going to be TOA. So I can use TOA here. I can use tangent. So tangent of 35 degrees equals opposite over adjacent. And so I have my equation. Now I can solve this equation by multiplying both sides by 125. And then at this point again, it's the job of the calculator. So x equals to approximately 88 feet. Number 7. You stand 40 feet from a tree. So let me first start with that. So here I am. This is an actual rendition of myself. And then here is a tree. Perfect. So it says you stand 40 feet from a tree. So at this point, I read that it says the angle of elevation from your eyes, which are 5 feet above the ground, to the top of the tree is 47 degrees. So an angle of elevation. So that means that from my eyesight here, so from my line of sight to the top of the tree, it's an angle of 47 degrees. I'm looking up to the top of the tree. But then it says that I'm standing 40 feet from the tree. So the distance from where I'm standing to the tree is 40 feet. So that's going to be this side here. So I'm 40 feet from the tree. So there's a 40 foot label there. And then it says, or then it asks, how tall is the tree? So I want to find out what's the height of the tree. So in this right triangle, I'm looking for the height of the tree, which would be this side here. The other part to this question that's a little different is here though, it says that my eyes are 5 feet above the ground. So what that means is that in this question, my actual height is going to be an additional 5 feet. So when it comes to solving for this missing side of this right triangle, I can do that first the way I've done it so far in this whole document. But that's when I solve for x, that's only going to be the height of this part of the tree. Because I made this triangle from my line of sight, which is 5 feet above the ground, once I solve for x, I'm going to have to add 5 additional feet to account for how tall I am, or my eyes are positioned as I look at the tree. So don't forget at the end, we have to add 5 more feet to to get the total height of the tree. So in this case, again, this is not a special right triangle, so I'm going to use SOHCAHTOA. So I'll just put that here on the side. Again, just to kind of write it over and over, I can memorize it better, and it's a good reference to have. Then I'll pick a reference angle, so here I'll pick 47. And here's my right angle, so here's my hypotenuse, opposite, and adjacent. So in this question, the hypotenuse isn't quite usable for me, so I'm not going to use that. So I'm going to use or focus on opposite and adjacent. That's going to be tangent. So picking tangent, I can write tangent of 47 degrees equals opposite over adjacent. And I can solve this problem. Oops, sorry guys, I made an error there. Adjacent's only 40 feet, I look at the angle. So from here I can solve this problem by multiplying by 40 to both sides. Then x here equals, again with the calculator, approximately 43 feet. But remember that that's only going to be the height from my eyes to the top. I now need to add 5 additional feet to account for my height. So the tree is actually closer to being approximately 48 feet tall. Alright, number 8. Guys, number 8 in this worksheet is meant to be kind of a challenge question. So in this case, I'm going to help you get started on this on the video, but I'm not going to do all of it here. This one we'll be doing in class, and I want to see how well you can just kind of mess with this one and see how far you get. So we can definitely start it off for you, but I'm not going to finish this one in particular just for that reason. So it says a satellite is orbiting 172 miles above the Earth's surface. So that's where you get from this satellite to the Earth's surface is 172 miles. It's only this piece, so I should give some color. From the satellite to the Earth's surface is 172 miles. When it is directly above the point T, the angle S is found to be 73.5 degrees. So that's already here on the triangle for you. Find the radius of Earth. So in this example, this is a right triangle. You can see it here. But it's not special, so I'm going to use SOHCAHTOA for this problem. So just know I'm going to still attack this using SOHCAHTOA. But know that in this problem it's going to be a little bit more complicated only because of the way that the triangle is labeled. So let's go ahead and go through the same process. First, I'm going to pick my reference angle to be 73.5 degrees. So this is my reference angle. And again, once I do that, my hypotenuse here is going to be the side across the right angle. In this case, the hypotenuse is going to actually be the side of 172, which is only this piece of this right triangle, plus the radius. So in this case, your hypotenuse is going to be 172 plus r. That's how you'd identify or label the hypotenuse. Next, from the angle that I've chosen, the side opposite is going to be the Earth's radius, so r. That's my opposite side. And then lastly, this is my adjacent side. So notice how in this problem, it's still just SOHCAHTOA. And again, in this case, the adjacent side is not given a value, so I really can't use this in this problem yet. So I'm not going to use this side. So what I can use is the opposite side and the hypotenuse. So that's going to be sine. So I'll give you the first setup, and then it'll be your job to try to work this out algebraically. So I can say sine of 73.5 degrees equals opposite, which is r, over hypotenuse. But again, in this case, the hypotenuse is going to be 172 plus r. So it's 172 plus r. At this point, it's going to be your job to try to solve this equation for r. So I'm going to let you guys kind of give this a try, and in class we can go over the response. Number 9. Here it's to solve the right triangle. So remember that when you see this instruction, it means you got to find all the missing angles and all the missing sides. You have to know all 6 values for the parts of the triangle. So in this problem, you're already given angle M is a right angle, and angle L is 20. So I'm going to find angle N. And this should be pretty quick because when in the right triangle, Since this is already 90 degrees, the two acute angles must add to 90 together. So this is 20, this has to be 70. So that's not that should not be a complicated value to find. Once that's done, you're being asked to find MN, which is this side that you don't know yet, and also LN, which is the hypotenuse. So in this problem again, this is not a special right triangle, so I have to use SOHCAHTOA. So I'll kind of set that up here in this problem. Now in this example, because you have more information given to you, you get to decide here what angle do you want to use as your reference angle. It doesn't really matter if you use 20 or 70. I'm going to use 20 just because it's pre-printed, but you could do it however you like. So given that I choose angle 20 as my reference angle, I can label this as hypotenuse. So here's my hypotenuse, here's my opposite side, and here's my adjacent side. And that's if I choose angle 20 as my reference angle. So with that being identified, then I get to choose which side to find first. Now I'm going to go in order just based on the questions being asked. So I'm going to first look for MN. MN is going to be this side here. And so in this example, the way I've labeled it, that's going to be the opposite side. So I can use O and A, since it's 11, I can use those two to start. So OA is going to be OA, or TOA, so that's going to be tangent. So I can write tangent of 20 degrees equals opposite, which in this case I don't know, so I'm going to just put the name of the side, over adjacent. And then here I can solve by multiplying both sides by 11. And again, at this point with the calculator, 11 tangent of 20 is going to be equal to approximately 4 units, whatever that is. So I found MN to be 4. To find the other side here, this LN, I could just use SOHCAHTOA again. So just to kind of keep things clean here, I'm going to write SOHCAHTOA one more time. And then here, if I want to now find this LN side, I could use, in this case I can use whatever I like, but I'm going to stick with my pre-printed values. So I'll use 11 again, and then H, this LN, so AH. So in that case, that's going to be cosine. So I can say cosine of that same 20 degrees is equal to adjacent over hypotenuse, which in this case I don't know yet. Remember, this is going to be a proportion in this example. So I can solve with cross product. So I get ln, which is the side I don't know, cosine of 20, equals to 1 times 11 is just 11. I can divide both sides by cosine of 20. So then I can find that this side ln is equal to, and again at this point with a calculator, 11 divided by cosine of 20 is approximately 11.7 units long. So I've now found all of the values. So here this equals to 4. This is about 11.7. Alright, number 10. In the accompanying diagram, which equation could be used to find x in triangle ABC? So here, you're kind of given the multiple choice problem. You have to decide which of these is an accurate way to find x. So to do that, let's solve it ourselves and see which one comes up in our work. So again, this is not a special right triangle, so we use SOHCAHTOA. So can I get that set up one more time? You guys, again, writing this over and over again, it's not required of you, but I'll just do it as a reference here, and it's good at practice in the beginning to do that, just to get used to seeing it over and over again. So, reference angle, hypotenuse, opposite, and adjacent. So in this example, I'm going to be using my opposite side and my adjacent side. So that's OA, that's going to be tangent. So already in this problem, the way that I've chosen the question, notice how if I look at the 4 choices, I'm going to be using tangent of 40. So this looks reasonable, this looks reasonable, this does not. So at this point, C already seems like it's going to be wrong. And then this looks reasonable. So at this point, I can already get rid of C as a possible answer. But I'll keep going. So tangent of 40 equals opposite, which is 19, over adjacent. And then from here, this is a proportion. So I can just use cross product. So x times tangent of 40 equals 19. And I can divide by tangent of 40 to both sides. And so here I find that x equals to 19 divided by tangent of 40. So if I scan my answers, B is the one that could represent how to solve for x. Notice how in this question, I'm not asking you to actually compute this. I'm asking you to choose from 4 options which is the correct step on the way to solve for x. So here B would match. Number 11. Again, in this example, I noticed that I have here a right triangle. But more importantly, I have here 2 sides that are labeled as x. So in this case, these 2 sides, since they're both x, they're equal to each other. So at that moment, if I have 2 equal sides, hopefully you will connect that I have to have 2 equal angles. And in that case, in my triangle, that means that this all of a sudden has to become a 45, 90. And so for this question, I can solve this, if I wanted to, with special right triangles. If not, though, I'll give you kind of 2 ways to do this, and you can decide what makes more sense to you. So in this case, because all 3 sides are given a value of some sort, I could use here the Pythagorean theorem if I wanted to. So I could say x squared plus x squared equals 6 squared. And I could solve that. Again, remember that it's a squared plus b squared equals hypotenuse squared. So that's one way to approach this problem. If I stick with my special right triangles, though, in this case, this is a 45, 90. So that in that triangle, the sides relate at a ratio of 1 to 1 to radical 2. In this problem, if you can notice here how the 6 is opposite the right angle, so here they're connected. So I can place the 6 underneath the 90 degrees. And I'm being asked to find the 2 smaller equal sides. Remember the logic here is if I have a longer side, I'm going to divide down. I'm going to divide down to find something smaller. And the ratio gives you what factor to divide by. So here I'm going to take 6 divided by radical 2. And if I work this out, I can in this case multiply the whole fraction by radical 2 or radical 2. This will allow me to clean up my denominator. So I get 6 radical 2 over radical 4, which is 6 radical 2 over 2. And here to finish, I can do one more thing. 6 divided by 2 is going to be 3 radical 2. So I found the length of these 2 missing equal sides. Number 12. If a equals 9 radical 3, so let me go ahead and put that right away here on a. So it's 9 radical 3. In the right triangle below, what is the values of b and c? So I'm missing these 2 additional sides. So again, in this example, if I look at it carefully, I could choose to use SOHCAHTOA, but if I recognize this right triangle, this is a 30, so this has to be a 60. This is going to be a 30, 60, 90 triangle. And so it's a special right triangle. So if I use that instead, if I can recognize this, I know that in every 30, 60, 90, the sides relate at a comparison of 1 to radical 3 to 2. In this example, you're given this 9 radical 3. This is across or opposite the 30 degrees. So here they're connected. So I'm going to place 9 radical 3 with the 30 degrees here. And I'm being asked to find the 2 longer sides of this triangle. So remember, for this to work, if I'm given the shortest side, which I am here, I can simply multiply up by each of these factors to find the longer sides. So to find this b value across 60 degrees, which is here, I'm going to multiply 9 radical 3 times radical 3. So multiplying up, that becomes 9 radical 9, but that simplifies to become 9 times 3, which is just 27. So this side across 60 degrees is going to be 27 units. To finish, if I want to find this c here, this is the hypotenuse. And we learned with this special right triangle that the hypotenuse is always double the length of the short side. So here, if the short side is 9 radical 3, if I double this up, in other words, take 9 radical 3 and multiply it by 2, 9 times 2 is going to be 18 radical 3. So I can very quickly find this other missing side. And I found B and C using special right triangles. Alright, number 13. So this is now a review of one of our main topics for this school year, which is quadratic equations or quadratic functions. And so in our next meeting, when we talk about the final exam review, we'll have a lot more of these to work on because that's a big part of the final. But for today, we have one. Kind of get us back into routine here. So I want to solve this quadratic function using any method. So I can try to factor if possible, take square roots if possible, the quadratic formula, which we know is always a usable tool. So here, remember, this is quadratic because it has a little square. And so in this case, this is in standard form. So I have my A value, which is 6, B is -1, and C is -2. In this case, this is not obvious to me that I can factor. So I'm going to just go ahead and find the discriminant to start. And so remember, the discriminant is a useful tool because it lets us know if we can factor, and also it lets us know how many solutions to expect when we solve. So this is a b squared minus 4ac. So again, this might look a little scary, but if you think about what I'm inputting, it's just a, b, and c, which I already know from the problem. So b squared, so -1 squared, minus 4 times a here is 6, and then c here is -2, so -2 goes there. Then I just work this out. So -1 squared is +1, and then -4 times 6 times -2, so we'll do it in steps. So -4 times 6 is -24. So -24. And then -24 times -2 is a +48. So when I work this all out, my discriminant is going to be 1 plus 48 is 49. Now at this point, because this is a perfect square, I can choose to factor this quadratic. However, in this problem, because I've already found the discriminant, I'm kind of already halfway done with the quadratic formula, so I'm going to just keep going with that for this problem. So I'm going to now use the quadratic formula. So that's going to be x equals -b plus or minus the square root of the discriminant all over 2a. But we've already found the discriminant. It says 49. So here we go. X equals -b. B here is -1, so I put a -1 in the parentheses. Plus or minus the square root of the discriminant, which we found to be 49, so it just goes right in there. All over 2 times a, but a here is 6, so that's going to go right in here. And then at this point I can just work this out. Sorry, let me make some space. Okay, so I get a negative times a negative is a +1, plus or minus the square root of 49 is going to be 7, because remember, 49 is a perfect square. It's a 7 by 7 square, so it's 7. All over 2 times 6 is 12. At this point, I can now separate this plus and minus into its two cases. So I can write 1 plus 7 over 12 and 1 minus 7 over 12. And then from here I can just, sorry guys, a little more space. Here I can just simplify this down. So 1 plus 7 is 8 twelfths. And then 1 minus 7 is -6 twelfths. Which ends up being 2/3 and minus 1/2. So in this example, I solved my quadratic equation by using the quadratic formula. And I found that I have two solutions, x equals 2/3 and x equals -1/2.